Okay, so here are the work solutions for the quadratic and other sequences section of the Year 10 Year 11 GAB book. So question 1. Here are the first 5 terms of a quadratic sequence: 1, 3, 7, 13, 21. Find an expression in terms of n for the nth term of the quadratic sequence. Well, first of all, we're going to find the first difference pattern. So that's plus 2, plus 4, plus 6, plus 8. Then we're going to find the second difference, which is always plus 2, and we halve this to get the number of n squareds that we've got. So that means we've got n squared. So now if we do our sequence and we write out the n squared sequence underneath it, so that's 1, 4, 9, 16, 25, and we're going to subtract the n squared sequence from our original sequence. That's n squared. Subtract. And 1 take away 1 is 0, 3 take away 4 is minus 1, then it goes minus 2, minus 3, minus 4. And then we do our nth term again to get from one number to the next in our sequence. We are having to take away 1, so that means that that's minus n. So now if we do the minus n sequence, and then if we do our sequence subtract our, so 0 minus minus 1 is 1, minus 1 minus minus 2 is 1, minus 2 minus minus 3 is 1, and every time it's 1. So that means that our formula is n squared minus n plus 1. Okay, here are the first 6 terms of Fibonacci sequence. The rule to continue the Fibonacci sequence is next term in the sequence is the sum of the 2 previous terms. Find the 9th term. So we've got 1, 2, 3, 4, 5, 6 so far. So the 7th one is going to be 5 plus 8, 13, then 8 plus 13, 21, and then 13 plus 21 is 34. 1, 2, 3, 4, 5, 6, 7, 8, 9, 34. The first 3 terms of a different Fibonacci sequence are A, B, A plus B. Show that the 6th term of the sequence is 3A plus 5B. Well, the next term is going to be B plus A plus B, so that's A plus 2B. That's the 4th term. The 5th term is going to be A plus B plus A plus 2B, which is 2A plus 3B. And then the next term is going to be A plus 2B plus 2A plus 3B, which is 3A plus 5B. Given that the 3rd term is 7 and the 6th term is 29, find the value of A and B. So that means 1, 2, 3. We know that A plus B equals 7, and the 6th term, so that's 3A plus 5B equals 29. Now we've got simultaneous equations to solve, so I'm going to times this by 3 so that we get 3A plus 3B equals 21, and then I'm going to subtract this one from this one. 3A take away 3A is nothing, 5B take away 3B is 2B, 29 take away 21 is 8, so 2B equals 8, so B equals 4. Now that we know that B equals 4, we know that A plus 4 is going to equal 7, so A equals 3. Here are the first 5 terms of sequence. Find the next term in the sequence. So let's see what we're adding each time. So that's plus 2, plus 6, plus 10. Then we are adding on 14. Then we are adding on 18. So if we look at our second difference, each time we are adding on 4 more than the time we were adding on before. So that means for the next term in our sequence, we're going to have to add 22, which will get us to 72. Okay, the nth term of a different sequence is 3n squared minus 10. Work out the fifth term of the sequence. We've got to substitute n with 5. So it's going to be 3 times 5 squared minus 10. BIDMAS says we do squaring first. 3 times 25 minus 10. Then we do multiplication. 75 minus 10 equals 65. Okay, here are the first 5 terms of an arithmetic sequence. That means we're adding on the same amount each time. Write an expression in terms of n for the nth term of this sequence. Well, we are adding 4 each time, like the 4 times table, so that means it's going to be 4n. But if we look at the 4 times table, 4, 8, 12, 16, 20, to get from the numbers in the 4 times table each time, we are going to have to take away 3 to get to the numbers in the sequence. Okay, find the nth term of a different number sequence. The nth term of a different number sequence is 3n squared plus 7. Find the 10th term. A bit like part B of question 3. We've got to substitute n, so it's going to be 3 times 10 squared plus 7. Square first. 3 times 100 plus 7. Multiply next. 300 plus 7 equals 307.